Hey everyone, welcome to the Pre-algebra 3.4 video about solving inequalities using addition and subtraction. So real quick, just by way of review, let's talk about what inequalities are. If you saw that, what would you say? Well, hopefully you would look at that and say that reads x is greater than 4. And hopefully you would remember then how to graph it as well. You'd have a number line, you'd mark a 4. You'd circle it, and then you would shade what direction? Well, x is greater than 4. This means all numbers that are greater than 4, and where are numbers that are greater than 4? They are to the right of 4, because you have 5, 6, 7, 8, 9, 10, 11, so on and so forth that way. Now, I wouldn't fill in the circle because it's just greater than. However, if it was x is greater than or equal to 4, I would still mark a 4, still circle it, still shade to the right, but because it's greater than or equal to, I would fill in that circle. So that's the difference. So let's kind of pick apart an inequality, and again this would be problem number 1, so we'll go down here to item number 2, talking about an inequality and what it's made up of. An inequality is really just, it's a statement that's formed when you place an inequality symbol, such as greater than, less than, greater than or equal to, or less than or equal to. When you place one of those signs between two expressions, okay, so an example would be x plus 3, there's an expression. 2x minus 7, there's an expression. And then when you place one of those signs in between them, let's take less than or equal to, that is now an inequality. Okay, just like x is greater than 4 was also an inequality. X is an expression, 4 is an expression, and we put an inequality symbol in between them. So let's talk about the solution of an inequality though. Okay, you're going to have a solution to an inequality when you have a variable. Alright, and you can show that solution by graphing, just kind of like we did up there. Alright, so we're going to kind of set up a little chart here. And I'm going to give you an inequality, then I want you to pause the video. I want you to tell me in words what it means, and then I want you to graph it. Okay, so if I give you this, what do you think the words are to that, if you were to describe that inequality in words? Well, I hope that you would say T, or you could use the phrase all numbers, okay? Talk about inequality. So all numbers that are less than -2, okay? All numbers that are less than -2. And if you were to graph that, I hope you go over here, select -2, circle it, and shade to the left, because that's where numbers that are less than -2 are. You got -3, -4, -1,000,000, so on and so forth. Now you wouldn't fill it in because this is just plain less than. It's not less than or equal to. Okay. All right. So this is kind of what we're the video is really about today. All right. We're solving inequalities. Now you notice this inequality looks a little different than the previous ones because we don't have the variable by itself yet. Got to get it by itself. Now how do we do that? Well, it's actually really simple. We operate on this the same way we would an equation. Why is m not by himself? Because there's a 5 being added to it. How do you get rid of a plus 5? You subtract 5. We got to subtract from both sides. And you get m is greater than or equal to 5. All right, simple enough. Now, what if they said solve and graph? Well, you remember you draw a number line. You'd mark a 5. It's greater than or equal to, okay, so you fill it in, and because it's greater than or equal to, shade to the right. That's as easy as it gets. So what about this one? Why don't you try this one, number 5. 7 plus k equals -2. Oop, not equals, sorry, is less than -2. I want you to solve and graph that. So pause the video, give that a try, and play when you're done. Alright, so hopefully you remembered, to get k by itself, I need to subtract 7 from both sides, because that's going to leave me with, well, those cancel, and I'm left with a positive k. And that's less than, well, let's see, -2 minus 7. Negative minus a negative, or a negative minus a positive, technically, is how this reads. -2 minus a 7. That's like adding the two of them if they were both positive, so 2 and 7 would get you 9, because it's a negative minus a positive, it's going to be a -9. You can also use the number line method, and say, oh, there's negative 2. I'm going to subtract 7, so I'm going to go to the left 7. 1, 2, 3, 4, 5, 6, 7, and that would give you your answer of negative 9. Now, this is not the graphed inequality. This is what the graphed inequality should look like. There's your little number. It's at negative 9. You're going to circle it, and you're going to shade to the left because K stands for all numbers that are less than negative 9. And if you notice, all numbers that are less than negative 9, K is less than negative 9, are down here. So you get negative 10, negative 12, negative 5,422, so on and so forth. All right, so we're going to solve and graph one more here. Okay, and let's see, you got negative 10 is greater than x minus 12. Now, how do you get the variable by itself again? Well, you have an x being, and they're taking 12 away from it, so to get rid of that minus 12, you add 12. But got to add 12 to both sides, all right? And so if you do that, negative 10 plus 12, I'll get negative 10. I'm adding 12 to it. That gives me a positive 2, and that's greater than x, right? So my question is, how does this read? Okay, how does your answer, your solution here read? 2 is greater than x. Yeah, okay, that's true. But I would caution you, and I would say I would probably switch the variable and the number, okay? Now, what do you do with the sign, though? Does the sign stay facing to the left or opening to the left? Well, no. What you need to think about is here in your first solution, you have the sign opening to the 2. So what you want to do is just make sure it continues to open to the 2. Now you can also think about it here. It's pointing to the x, so down here it still needs to point to the x. So saying that 2 is greater than x is the same as saying x is less than 2, right? They're saying the same thing. This is the preferred way because when you go to graph it, I think it makes it a lot easier, right? What's your number? You mark a 2, and you're going to shade where all numbers that are less than 2 are. So x is less than 2, open circle, shade to the left. That's where all numbers that are less than 2 are. All right, so what do our solutions mean here? Okay, so we call this our final solution. X is less than 2. What does that actually mean? Well, it means that, first of all numbers that are less than 2 are our solution. So, for example, one of our solutions would be 1, because 1 is less than 2. Another solution would be 0, because 0 is less than 2. Negative 4, or 7, I'm sorry, is also less than 2. So it means we have multiple solutions. Now, what do we do with, how do we check our answer, I guess? Well, let's rewrite our original. Negative 10 is greater than x minus 12. And again, we said the solution was x is less than 2, and then over here were some examples, okay? So what we want to do to check our solution, or check our answer, is plug in the solution into here for x. Now, keep in mind, I'm not plugging in just one number for x, or there's not one number that I can plug in that's the right number. There are a lot of right answers, okay? So x is less than 2. So one of those solutions that fits that is 0, because 0 is less than 2. So I'm going to plug in a 0 for x. So now I'm going to have negative 10 is greater than 0 minus 12. Okay. Now, how do I simplify that? Well, we're just checking to see if there's, if this gives us a true statement. So negative 10 is greater than 0 minus 12. That gets you negative 12. Okay, so notice we don't have any variables anymore, so we just have a statement. And let's see if this statement is true. Negative 10 is greater than negative 12. Well, if I had a number line, and here's 0, that would be negative 12, and that would be negative 10. So yeah, negative 10 is definitely greater than negative 12 because it's closer to 0. So this is a true statement. So we checked our solution, and it's correct, okay? Now you could also plug in a 1 for here and get a true statement. You could plug in a negative 4 and get a true statement. Any number that is less than 2, you would plug in for here, and you would simplify each side, and you would get a true statement. And that's how you can check your answer. Now we can also check our answer by doing this. Let's rewrite the original. And what I can do is I can plug in an answer that does not fit with that. So x is less than 2 is our solution. So let's plug in a 4, which is not less than 2. So if plugging in a number that's less than 2 gets us a true statement, plugging in a number that is greater than 2 should get us a false statement. So let's plug that 4 in there. negative 10 greater than 4 minus 12. Let's see. Negative 10 is greater than 4 minus 12 is negative 8. All right, so what kind of statement is that? Well, up here, this was a true statement when we plugged in a number that was less than 2. Here, we get a false statement. Okay, a false statement because negative 10 is not greater than negative 8. Negative 10 is actually less than negative 8. So there's another way to check your solution. All right, so you are going to be competing in a triathlon. Triathlon, not triathlon, triathlon. Okay, and let's say last year you competed and you finished in 85 minutes. Okay, that was your time for last year. Now, you want to beat this year's time. Okay, and so you're off, right? And you've swam first. Now, then you've biked, and now you're about ready to start running, okay? And you heard that your swim time, and this is now, so we'll separate this a little bit. Last year's was 85, and this year, your swim has taken you 16 minutes. Your biking has taken you 32 minutes. Okay, and so the question is, what is your run time going to have to be in order to beat your overall time from last year? Okay, so last year you were 85 minutes for all 3 events, okay? So how can we figure that out? Well, we could start playing with some numbers and stuff like that, but what if I said we need to set up and solve? I think it's actually the wrong way to use set up. I think it should just be set space up. Set up and solve an inequality. Okay. Well, what's the inequality going to contain? Well, we're trying to beat what? Last year's, okay? And we know last year's total time. And again, whenever we see a total of some sort, I want to write it. Okay, so we're doing last year. And I want to set it equal to. However, we're doing inequality, so we don't use an equal sign, but we use greater than, less than, greater than, or equal to, or less than or equal to signs. Now, what do you want to do to last year's time? You want to beat it, which means that this year's time has to be less than last year's. Okay, so last year's needs to be greater than in order for you to beat this year's time. Okay, so last year's time was what? Well, we say 85 minutes. And that's going to be greater than this year's time. Now, how do we know this year's total? Well, we don't yet, but we do know some things. We know you swam for 16 minutes. We're adding to that 32 minutes of bike time, and now we're adding to that an unknown amount of running time. Okay? So now we have an inequality that we've set up, and now we can solve. Now, how do we solve? Well, we simplify the left side first. Can't simplify anything there. Let's simplify the right side, and I can do that by combining like terms. So if I take 16 and 32, add them up, 32, so 42 plus another 6, give you 48 plus r, all right? And then you just lastly solve by subtracting 48 from both sides. Okay? And 85 minus 48 would get you, let's see, 37 greater than 48 minus 48 cancels r. Okay, so what do we know here? Well, we know in order to beat last year's time, well, you have to get under 85 minutes because last year's time you were 85 minutes, so in order to beat it, you have to get under 85. But since you've already swam, you've already biked, what does our solution tell us? Well, it means in order to beat last year's time, you need to get a run time that is less than 37. Now, I'm reading that from right to left, but if I rearrange the terms, I put r there and 37 there. Let's see, the sign is pointing to the r here, so I need to make sure it still points to the r. This says r is less than 37. Okay, now this is the same as saying this, 37 greater than r, same thing. I think it makes more sense to read it this way. So it means that as you take off running, your goal needs to be to run the rest of the race under 37 minutes, and that will allow you to beat your total time from last year.